So, if you're curious about calibrating with just one sensor on the pelvis and two on the feet, I just wanted to show you guys first what the calibration file looks like. I recommend going ahead and going back to that 10-meter walk test knowledge base article just to check out that full calibration procedure. But just running through the poses in the calibration file, you have your standing pose, your bowing pose, which calibrates the sensor on the pelvis, the left leg pose, which requires a tilt on the foot, the right leg pose, which requires a tilt on the right foot, and then just back to that standing straight pose. So this calibration can be done in seconds and is pretty easy with just a few sensors or even just one sensor. So I'm going to go back to my database and pull up a running recording. So we'll go ahead and just take a look at this first. I'll fast forward to where, that run is actually occurring. And as you can see, just one sensor on the pelvis and two on the feet. So what's nice about having the foot sensors is that you have contact detection. So this is something that is available with the foot sensors for the motion system. But one cool thing that you can look at here is, if you have another system that is doing the contact detection for you, like an insole or a pressure platform or 2D markerless even, you can actually use just the pelvis sensor without the feet to get some interesting insights here. So what I'm going to do is I'm going to open up my Translation Toolbox, navigate to my single sensor options, and I'm going to set my timeline as well as set my closed loop drift correction criteria here. So for instance, I'm going to go in and first highlight the section that I want to analyze. It recommends keeping that selection to about 10 seconds here. But kind of the nice thing is that we can actually correct for vertical drift during gait activities. So I'll hover over this here so we can read the tooltip. That'll automatically apply vertical drift correction during detected gait activities. So this is valid for the pelvis sensor or even the spine sensors if you're placing that single sensor elsewhere on the body. So we can get away with a bit of a longer interval if we select this correct for vertical drift during gait. This is going to be key for gait and running activities. So in addition, we're going to zero our vertical displacement between the end and the beginning of the recording, as well as our horizontal displacement. The sensor we want to use for our calculations is the pelvis. So we simply want to set intervals and process. And immediately we're going to have all these signals for the pelvis. So again, lots of different signals here that can do lots of different things. And give us lots of information that can be really interesting. So, progression distance, lateral distance, total speed. In this case, I'm particularly interested in the vertical displacement as well as the vertical velocity. So I'm just going to throw these into a different tab so we can evaluate them further here. But that vertical displacement is going to be a proxy for that center of mass displacement during running. So we can evaluate, when is that center of mass at its peak? When is it at its minimum throughout the whole running cycle? And just looking at the vertical velocity is very interesting as well because we can assess how quickly that center of mass is moving. If we go back to our full signals here, we can even evaluate the total speed of the pelvis sensor or even the lateral displacement if we're interested in viewing how much side-to-side movement there is of the center of mass. So a lot of really interesting information that you can derive here just from calculating those speed and distance metrics. So I'm going to go back from the Translation Toolbox and show you guys a report that I've already defined based on these sensors. And that is called this 3-sensor running analysis report. This report is actually derived from our regular MyoMotion running report. So you get all these phase and time parameters just from that contact detection already. And then in the curve analysis, we can evaluate that pelvis sensor vertical displacement through the stance and the swing phases of the gait cycle pretty easily here. And then we can evaluate that range as well. Since this is given in meters, it's going to give us a pretty small range here. So what I can do just to make that a little bit easier is change the number of decimals reported for the range of that center of mass displacement throughout the gait cycle, where you can see how much displacement there is throughout the stance phase and the swing phase. Some small edits you can make here just by double clicking. You could add the maximum center of mass displacement as well in your diagram statistics tab. So that can help you evaluate running efficiency over time if you're doing pre and post analyses with any runners. So I also wanted to show you with that another option that you can utilize if you have alternative contact detection. So let's just say we have 2D markerless running and we want to use just one sensor on the pelvis to derive that center of mass displacement. If we want, we can go to our report menu, and if you are doing your running analysis with the markerless, you can go ahead and choose our default markerless POI running report, and then we can do that tracking here. So we'll go ahead and just track, the middle 5 seconds, click next, and wait for that tracking to finish. So once the report is available, you can see that since we only did tracking on one video, we just have that left side sagittal plane here. So if you have more cameras, of course, the information about joint angle analysis at these different points of interest is going to be a bit more complete. But in general here, if we scroll down to the bottom where we have these average curves, we can double click to edit this element. And then in our analyze signals and intervals, we can just go ahead and add our pelvis sensor displacement. So I'm looking for pelvis sensor vertical displacement here. I'll go ahead and check the box, make sure that's in our selection result, click OK, and you have the same exact information that we just saw in our other report based off of the default myomotion report as well. So you can continue to double click to enter the settings, go to your diagram statistics, add things like the maximum or the range, change the decimals if you want, and that will be added to your report as well. So you can do this with any report that you're using in our software, the Ultium insole reports, if you're using insoles for contact detection, or even the myomotion reports. The last thing you can do is save this template as new if you are making modifications. So I can go ahead and just call this markerless POI running with vertical displacement. Click OK. And then that report template is going to be available for me to run for other recordings in the future.